Hi, my name is dr. Ahmath. In this video lecture, we are going to discuss about integration by parts. In particular, we are going to solve 4 problems taken from the online quiz. For full description of the online quiz, please go to the link below. The first problem which we would like to solve is simply the integration of the x times the cosine of 5x. Again, in order to solve this problem, we are going to use this formula u dv is equal to the uv minus v du. So you can see here that the first thing which we need to do always is to choose what is going to be the u and what is going to be the v. And I would always choose a function as the u as the one which is going to be eliminated if I take its derivative. So in this regard, if I choose the u to be equal to the x, simply du is going to be simply dx. So you see, so the x disappeared after one iteration, and the rest of the thing which is left here, the whole of all of these things, so cosine of 5x times as a dx is going to be denoted as the dv. And the v is going to be the antiderivative of this. It is going to be the sine of 5x. This is the antiderivative of the cosine of 5x. And I have to additionally divide this to the 5, because if you take a derivative of a sine of 5x, it is going to be cosine of 5x times the 5, right? So you need to take care of this 5 additional taken from the argument of the sine. So now we are going to use this formula, so the uv. So this integration is equal to the uv, which is x times to the sine of 5x over 5, minus the integration of the v du, or v du here. So it is going to be the integration of the sine of 5x divided to the 5 dx. Well, and the integration of the second part, it's not so difficult, so it's pretty much straightforward. It is going to be x times the sine of 5x divided to the 5 minus the integration of the sine, it's cosine, or minus cosine, I would say. So that is why it's going to be plus here. So you are going to have cosine of 5x divided to the 25, because this sine is going to give you additional 1 over 5 plus some constant. So this is the answer for this problem. So let's go to the second problem. So in the second problem, we need to evaluate the integration of the ln square of x. So if you remember in the lecture, in a video lecture, we try to integrate simply the ln of x. So here we have to integrate ln square of x. It appears we can do this. Again, so I'm going to choose as the u the ln square of x. dv is going to be the rest of the thing, which is going to be dx. Then du is going to be derivative of the ln square of x, and I need to use the chain rule, so it is going to be 2 times the ln of x. I need to look to this as the power function, right? So as x in the square, and then multiply it to additionally to use the derivative of the ln of x, which is 1 over x. dv is going to be equal to the integration of the dx, which is simply, so v is going to be the integration of the dx, which is the x simply. Then I'm going to use the formula again. So uv, it is x times to the ln square of x minus the integration of the v du. It is going to be x times to the, I forgot about the dx here, x times to the 2 times to the ln of x times to the 1 over x dx. So you can see here that in the second integration, we just need to integrate 2 times to the ln of x. So I'm going to integrate ln of x separately here. So the integration of the ln x is going to be again done using the integration by parts. U is going to be ln of x, dv is going to be equal to the dx. So I forgot about dx again. So du is equal to 1 over x dx, and v is going to be equal to simply to the x. Then this integration is going to be equal to the uv, which is x times to the ln of x, minus the integration of the v du, which is the x times to the 1 over x dx, which is simply x after the integration. It is going to be x ln of x minus the x, and we have to substitute this t here. So well, it is going to be x times to the ln square of x minus the 2 times to the x ln of x. So I think it's going to be plus now 2x, right? Because this minus multiplied to here, it is going to be minus. And if you multiply this to this minus, it's going to be plus. So plus some constancy. So this is how we can integrate ln square of x by just iterating this twice. So well, the next problem is going to be even more interesting because we need to do a couple of iterations, and even though we are not going to get the answer explicitly. So I'm going to choose again u to be equal to the e in the power of 2x. The rest of the thing, which is dv, is going to be equal to the sine of 3x, dx. du is going to be the derivative of the e in the power of 2x, which is 2 times to the e in the power of 2x dx, right? According to the chain rule, you have to take the derivative of the 2x separately. And then v is going to be the antiderivative of the sine of x. I think you're experienced enough now to find the antiderivative of the sine of 3x, which is going to be minus cosine of 3x over 3. Then according to the formula, it is going to be equal to the uv, which is e in the power of 2x, minus 1 over 3, or minus cosine of 3x over 3, minus v du. It is going to be, what's the plus now, because I've got minus under v. It is going to be cosine of 3x divided to the 3 times to the 2 e in the power of 2x dx, right? So essentially 2 over 3 e in the power of x times the cosine of 3x. Now let's integrate this second integration by parts again. So I'm just going to write down this 2 over 3 separately, and I'm just going to use this e in the power, e is going to be e in the power of 2x is going to be u. dv is going to be the rest of the thing. So I think I'm going to write down 2 out of 3 separately. I'm going to write this cosine of 3x dx. Then du is going to be equal to the 2 e in the power of 2x dx again. And the v is going to be equal to sine of 3x divided to the 3 dx. Without dx. Sine of 3x divided to the 3. Again, according to the formula, it's going to be 2 e in the power of 2x, e in the power of 2x times the sine of 3x over 3, right? Minus the integration of the v du, it is going to be equal to the 2 over 3 sine of 3x to e in the power of 2x, and its integration dx. And we have to substitute everything to here and multiply this additionally to the 2 over 3. Well, so you see, we started from this integration of the e in the power of 2x times the sine of 3x, and we ended up with the same integration. But we never give up, so I think we need to look to this integration in a bigger screen, or in a bigger picture. So e in the power of 2x times the sine of 3x dx is going to be 1 over 3. I think I made a small mistake, so I have to multiply this to the 2 over 3 additionally, and this should be also 4 over 9, I think. So 2 over 3 times the cosine of 3x minus 4 over 9 of the integration of this. So please note that you need to evaluate this integration, right? So you can take this integration and put this to the left-hand side, and 4 over 9 plus 1, it's going to be equal to the 13 over 9. And it's integration of the e in the power of 2x sine of 3x dx is equal to the 1 over 3 e in the power of 2x sine of 3x minus the cosine of 3x. So we can cancel out this 3 with this one of the 3's, and the integration is going to be equal to 3 over 13 e in the power of 2x sine of 3x. Sorry, I forgot about 2 over 3 again. So minus 2 over 3 cosine of 3x. So this is a little bit complicated example. We need to do the integration by parts twice, and even though we're not going to get the answer explicitly, so we're going to do a little bit more manipulations in order to find the integration. But here is a trick. For all of this kind of problems, when you are going to multiply the two functions, which are not going to be eliminated even one iteration. So this is e in the power of x and the trigonometric functions. And our last example is about cosine of x times the ln of sine of x dx. At a first glance, you might think that it is a very complicated problem, but it is not actually, because we can see a function and its derivative inside the integration, right? And in this case, we need to use the substitution rule. So the rule of the substitution actually tells us, or the postulate of the substitution rule tells us, that if you see a function and its derivative, use the substitution rule. So I see the sine of x here, and I can denote this as a t, for example. Then dt is going to be derivative of the sine of x, which is cosine of x, times the dx. You can see here sine of x and cosine of x dx, right? And now I'm just going to substitute everything which is related with the x with the t. So in this case, cosine of x times the dx is going to be simply dt. And the ln of sine of x, it is going to be ln of t. And we already know what is the integration of ln of t. We did this before, but I'm going to show you this one more time. So the u is going to be equal to the ln of t. dv is going to be equal to the dt. Then du is going to be equal to the 1 over t, and v is going to be equal to the t. Then this integration is going to be uv, which is t times the ln of t, minus the integration of t times the 1 over t. I forgot about dt again. So dt, which is the integration of 1, which is simply t, right? It is going to be t, so this t and t are going to be cancelled out. T times the ln of t minus the integration of 1, which is simply t, plus the constant. Though that's going to be the integration, so if you want, you can re-substitute everything back to the original function, original argument. It is going to be equal to the sine of x times the ln of sine of x minus the sine of x plus the constant. Well, this is how we can validate integrations using the integration by parts. The main rule is the integration by parts is very useful when you have to integrate the multiplication of the t functions. And the most important part for the integration by parts is your choice of the u and dv. Well, thank you very much for your attention. I hope that this was helpful for you.